long enough for you to go tick, 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 and then I'm going to take it off. And then I'm going to go to the second page and do it again. And later during your work time, I'm going to walk around and see how much of this you actually did. That bottom one is 15.6. All you need to do is tick, 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 or X, 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 X. Don't worry about the little rabbit I drew there. It's badly drawn, and I don't need you to make fun of it. But all of you saw it and said, oh, Mr. Myers, why'd you draw a rabbit? Right? Of course you did. But really, it looks like one of those dogs with a scooter because it's missing its back legs. But, Karen, whatever it was, whatever the work I gave you, it's these two Pythagoras sheets, whatever they were.
Quick question about the test. Is that inches thing going to be on it?
Is it? Is that a conversion?
No, not the conversions. The inches where you're just like...
Where I ask you to show me how to measure something?
Yeah.
On a test on measurement, do you think I'm going to ask you to show me how to measure something?
Yeah.
Do you really need to ask that question? A better question might be, are you going to ask us what the scientific name of an elephant is? Because that would not be on a math test. But on a math test about measurement, I might ask you to measure things, right? It seems only fair. And that is all for that. I will be around in a moment to check on those. If everybody would be so kind now as to flip to page, no, not 53, I'm the worst kind of liar, to page 49, please. Oh, I hate liars. We skipped these pages because I wanted to make sure we got to Pythagoras. Yes, on Friday, because it was nothing new. This might be new, and I didn't want to cram it into your brains on Friday. So, in order to study trigonometry, we all must be on the same page for how we discuss triangles, how we name them, how we orient ourselves around them. Now, I apologize if your grade 9 teacher did this for you, but most of the classes that I have dealt with so far did not have this shown to them in grade 9, which makes doing trigonometry in grade 10 a super pain in the butt. So, I'm going to do this now. Again, if you want to write it down, write it down. If you want to pay attention, just pay attention and check the video later. I do not care. All right? Because there's a lot of theory here for the next 5-10 minutes. All right? We will start with a couple of words that you hopefully you know, maybe you don't. Angles have two sides which have a special name and a point. The point is what I'm concerned with. The point is called a vertex. If there is one of them. If there is more than one of them, they are called vertices. So I'm going to go ahead and I'm going to draw some angles. How many vertices did I just draw? 4. Excellent. 1 at that corner, 2 at that corner, 3 at that corner, and 4 at that corner. Is everybody cool? Yeah. If 2 lines cross, they make at least 1 vertex. If they continue, they make more. Everybody is good? Yeah. Awesome possum. Okay. Triangles are named by their vertices. So I'm going to highlight the word vertices, and I'm going to put a yellow box around each vertex. So this triangle would be named either triangle ABC or triangle CBA or triangle BAC. Everybody cool? We just go corner to corner to corner. The most popular name for that triangle would be ABC because it's alphabetical. Everybody knows this, yes? Okay, that's how we name the triangle. Now please note that is not the type of triangle it is. That is the name of that triangle. Everybody with me? The type of triangle that is scalene, but that's not important. Everybody cool? That's how we name them. All right? Angles are named two ways. Way one is by vertex in uppercase letters. Way two is by all 3 points. So I'm going to use blue to label A. Name it. There are 3 ways to name A. This corner, this vertex. It is either angle A with a capital letter, or it is angle BAC, or it is angle CAB. What do you notice about all 3 ways of naming the angle? What is common? The A. The vertex is the most important. Is everybody cool with that? Good. That means all of you should be able to name all 3 versions of C and all 3 versions of B. Go. So what is the first and tidiest way to name the green angle? Angle C. What are the other 2 ways? A, no. ACB or? I already got ACB. BCA. And what are the ways to name the purple angle? Angle B, angle ABC, and angle CBA. Can everybody do that?
Yeah.
Excellent.
Well, I have a question.
I have an answer.
Why is that letter always in the middle of it?
Because it's the vertex. You go point to vertex to point. So now all of you should be able to do those 3. That's supposed to be an E. I hope it shows up better on your page. So what are those 3? I'm going to name them over here. Can everybody name angles?
Yep.
All right. So if I asked you to put your finger on angle FED, you could all do that. Right? Everybody could do it? Excellent. Now, You are very intelligent young people. Triangles have 3 angles. What else do they have 3 of? Sides. The sides also need names. So I'm going to change color to red, and we're going to talk about the sides. Sides are a little more confusing. They still have 2 ways, but the labeling is different. Way 1. The side is labeled with the lowercase letter, and I'm going to underline lowercase letter, of the opposite angle. What does opposite mean in this unit? Across. So, we're going to go up here, right here. I'm going to highlight this line yellow. That side needs a name and a label. What would I name that side and label it with? Lowercase letter of the opposite angle. So I'm here. What's opposite from me? B. So this is side lil b. Everybody cool? What does that make this side, which I'm going to highlight in bleu? Lil a. And what does that make this side, which I'm going to highlight in green? Lil c. Oops, I was doing all these in red. Is everybody cool? Great. Now you do that down here. Yellow, green, blue. What is the yellow guy going to be? Lil E. What's the blue guy going to be? Lil F. What's the green guy going to be? Lil D. Everybody cool? All right. What if I told you this was big lightning bolt? What would this be? Little lightning bolt. What if I told you this was big dollar sign?
Small cent.
Yeah, you could be a wise ass and say cent, or you would go little dollar sign. Everybody cool? All right, good. Remember I said it gets a little hairy here. There's another way to label them. Sometimes we label them by their end points. And if we label them by their end points, we use caps still. We use uppercase. And that's what I mean by it's confusing. It just depends on the question. I will always try to use the opposite angle, but some people will say this side is DF or FD. Everybody with me? So what does that make this side? FE or EF. What does that make this side? DE or ED. Is everybody cool with how we name triangles? Yes? Okay. Now, in the interest of time, we're going to do a little bit of work with this. I'm going to tell you right now that angle A is 30 degrees. Angle F is 30 degrees. Angle D is 95 degrees. Angle E is 55 degrees. What does that make angle C, do you think? 95. Absolutely correct. And B? 55 degrees. When you turn your page over, you're going to see a bunch of charts, and you're going to see angles written all over them. Don't worry about the angles. I'm going to tell you what that means right here. I want to change colors because I'm not dealing with either of those specific things anymore. If two triangles share the same angles, They are similar. And there's a symbol for that. It's a squiggly equal sign. Similar shapes are why we can draw a picture of this building on a piece of paper this big and turn this building into this. Yeah, it's all about ratios. Okay? That property is what allows us to do that. Now, if I tell you that triangle ABC is similar to the second triangle on the page, I'm interested to know who can figure out the proper name for the second triangle. I'm going to shrink it down so we can see it all at once. Who can figure out the proper name for that big triangle if I name the first triangle ABC? The second triangle's down here. It's got different corners. How do we name triangles? By the corners. FED. Why? Why isn't it DEF? Because you have to follow the same pattern. I went A, then I went from the 30 degree to the 55. So I have to do the same thing down here. FED. Everybody understand? All right. Now, listen to me, please. If you have a ruler available to you right now, even if it's tucked away in your binder or something, get it out, please, and measure, like it says on the second page, the length of ABC and DEF, please. If you don't have a ruler, it's no big deal. But if you do have a ruler, measure them and tell me what you get. Don't use that ruler. It's been printed and photocopied. I don't know how exact it is. But it would still actually work for what I'm about to teach you, because concept-wise it would work. When you have one of these distances in centimeters, just yell it out. Any of the 6 that I've asked you to do. We're not measuring angles, we're measuring sides. Somebody must have a distance for me now. It doesn't take that long to measure a line. It's not a trick question. I see people with rulers. Put the ruler on the side of the triangle and tell me how long the side of the triangle is. Anyone, I beg you. 7.3? On which one? A? 7.3. Thank you. Can anybody give me any one of the other 6?
11.4.
For which one? 11.4. So that is this side. Great. Does anybody have another one?
Hold on.
You sure?
Yeah.
Okay. 11.4, I think he said.
Yeah, no, 7.3 is B, and then C is 8.0. And then A is 4.5.
Remember 2 seconds ago where I said, is everybody cool with how we name the sides?
Yeah.
And everybody sat there? Yeah. And remember how I showed you the picture? And I said, everybody's cool?
It's labeled
Okay,
out.
everybody's cool. Okay, how long is side A? Take your ruler, find side A, which is right here, and tell me how long it is. 4.5. Okay. How long is side B? That's right here. 7.3. Awesome, possums. And how long is side C? 8.8. Excellent. Now I will change colors. And how long is side D? 13.9. How long is side E? Whatever. How long is side F? Okay. You got it. Okay, now, I am asking you right here to give me a fraction. What is the measure of side A, which is 4.5, divided by side F? Why am I comparing it to side F? Because they're in the same relative position on the triangle, between the 30 and the 55, right? So when I compare those two, what math happened right there? Division. And what do you get when you do 4.5 divided by 7? 0.64. Now, what happens when I do B and E? You go to jail. And E is 11.4. What does that give you? .63. So now, without even thinking about it, what is 8.8 and 13.9 going to give you? About the same thing. Why aren't they all exactly the same? Haram. Pardon me? Yes, of course. Why aren't they all exactly the same? Yeah, the measuring isn't perfect. If we had perfect measurements, these decimals would all be the same, yes? And that is why this works. If I drew that triangle on a piece of paper, it would look like this, and it would have a measurement of whatever, 3 centimeters by 2 centimeters, right? In real life, it's much bigger. This has a real life measurement and a real life measurement. Whatever this number is on the plan multiplies by a scale factor, which gives me the real life number. Everybody cool? If it's enlarged, it's multiply. If it's shrunken, it's divided. That's how it works. That's why we can build stuff from little plans, which is also the basis for trigonometry. Is everyone cool? Now I want you to notice something before we go any further. Did the angles changed when I changed the length of the lines? Would they? If I drew this line, this yellow line, all the way back to you, Ting, and this green line all the way over to Hayden, would the 30 change? Why? Because it's where they meet is where they meet. Right? Okay. Everybody is cool really now? Not like we were cool 5 minutes ago when I said measure side A and I got 27 different answers? You're approaching cool? Like there's those kids in the cafeteria that you want to sit with and now you're sitting at the table right beside them but not at their table. Okay. All right. Would it help if you took one more little crack at it? Like if I drew a triangle right here and I told you that was big X, big Y, and big Z, could you tell me the sides?
Yeah.
You could.
Yeah.
What would this one be?
Y.
Lil Y. What would this one be? Lil X. What would this one be? Lil Z. And if I told you to measure side Z, would you put your ruler on the blue, green, or purple one? The green one. Okay, what if I did this? I want you to measure side N. I want you to measure side ON. I want you to measure side NM. All right, you are cool. I would let you guys sit at my math table.
I'm so cool. I got
All right. Okay, everybody turn to 53, please. Before we get started, I need you to do two things. Do you see this little black dot by the C?
Yeah.
It's supposed to actually be beside the C.
That just messed me up. I don't know if I can do the worksheet now. I don't know.
And see that little little black dot by the D? It is also supposed to be one higher.
Oh, man.
What about the other ones?
The other ones are cool. I don't know what happened.
How did you realize that it was wrong?
Because when I did the lesson, it screwed up. And I was like, damn, son. All right. Is everybody cool? All right. Now, all you have to do is follow the instructions. Draw a line. And actually, I'm going to change these instructions because I realize they're better off doing what I'm about to do. Just connect A and F right now. You don't even need a ruler because you can just go right along the line on your, because you guys have graph paper too. And then connect B and F. What angle did I just make? A 90-degree angle. What would you name that angle right now? There are three options. Angle F. No, that's the type of angle it is. Give it a name. Angle F or AFB or BFA. Good? All right. Now, I'm going to make that a triangle. Everybody cool? Now, that gives me this blue angle right here, yes? All right. Now, from that blue angle, I want you to compare BF and AF. So how long is BF? You can just count. You don't even need to measure. BF, dude. BF. 3. How long is AF? 4. So there's a ratio of 3 to 4, yes? Now, what's another way to write a ratio? As a fraction. How would you turn this into a fraction ratio? 3 over 4. Ooh, we are on fire today. Now, since you're all Canadian students and you're scared to death of fractions, what would you do with that if I wanted you to do any work on your calculator with it? 3 divided by 4. And what would you get? A decimal that is what? 3/4. How much is 3/4? 0.75. Woo, doggy. Everybody cool? Everyone cool? Okay, now, I'm going to erase the red, but I don't want you to erase yours. And I'm going to switch to orange. And now I'm going to go all the way out to G and all the way up to C. Oops, I got a little snaky there. All the way up to C. And I'm going to complete that line. What did I make right there? 90 degree. Did the angle of A change? I made the triangle way bigger, but did A change? You can. Now, I would like you to compare CG to AG. You can just count on your paper. How big is it? Nine, because CG goes first, and then 12. Write that as a fraction. 9 over 12. Would Mrs. Bad Crumble allow you to write 9 over 12? Of course not. What would she want? 3/4, which would get me what? 0.75. Now, the last thing with pink. I'm going to erase the orange. I'm going to go all the way out here. I'm going to go all the way up there. And now, do I still have a 90 degree? Yep. Do I still have angle A? Did angle A change?
No.
What do you know DH over AH is going to be when I do the division? 0.75. I don't even need the fraction, do I?
Nope.
Because this has to equal 0.75. Now, you're intelligent young people. If you know this is 0.75, and I tell you that A to H, which is the denominator, is 20, can you find the last number without counting? What would you do? 0.75 times 20 would get you this, and it would be 15. Is everyone cool? What if I drew this pink hypotenuse all the way back to Yuting, and this pink bottom line all the way over to Hayden? What would happen when I measured the distance from Yuting to Hayden and from Hayden to me and then divided it? What would I get? 0.75. What if I drew this pink hypotenuse all the way to Whistler, and I drew this pink leg all the way to the northern end of Stave Lake, and I divided the distance between Stave Lake and Whistler and me to Stave Lake? What would I get? 0.75. What if I drew this line all the way to the Queen Charlotte's? Wait, Haida Gwaii. And I drew this line all the way to Prince George. What would the distance from Haida Gwaii to Prince George divided by the distance from Prince George to me? 0.75. Yeah. Because size of triangle doesn't affect the angle or the comparison between the sides. Now let me ask you this. What if I put this light blue line right there? You can quite plainly see that that's 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
Yep.
So that would be the denominator, right?
Yep.
And I know the fraction must be what? 0.75. Can you use your knowledge to tell me this distance? What would you do? Right now, it's unknown, so it's x. What would you do? You would do 0.75 times 9, because we just practiced a crap ton of algebra, didn't we? What if I gave you this one? I told you it's hard to do with vertical. That one. No, because that doesn't work. Can't really do it with vertical because it's not exact. Is everybody cool?
Yep.
Now, here's where you have to actually prove you understand something. What would make this decimal change? If the angle changes. How do I change angle A? Which of these two sides would have to move? The green, or the blue? One of them or both of them, right? As long as that angle changes, this decimal is not going to be the same, right?
Yeah.
What if I made it taller? Would that decimal get bigger or smaller than 0.75? Bigger, right? Because I would have 12 over 4 or whatever, correct? What if I made it smaller? Then it would be less than 0.75. And how would we find that decimal? We would take this measurement and do what with it? Divide it by this measurement. Does everybody understand? All right, take a nice deep breath. Get out your calculator, because now we have to do something that's a super pain in the butt. So everybody get out your calculator, take a nice deep breath, and let's get ready to do some more work.
Okay, really quick.
Go really quick. You literally have 1 minute. Go. No. Because what if I drew this triangle? This is the small number, this is the big number, right? Right? But what if I drew this triangle? Then it's big. So it's not small and big. What is it? Because you're going to the very next point I'm going to ask you guys. You're so close. This is the angle I was dealing with, yes?
Yes.
And it was always that one divided by that one, right? That one divided by that one, right? Did it matter about the length? It was position on the triangle. Okay? And you're like a half a step ahead of where we need to be, which makes me so happy that you're thinking about it. All right. Okay. This ratio that we just made is called the tangent.
Is that what that
ratio. I'm getting to that. Don't give me away, Nicholas. And it holds true for all right angle triangles. Now we're going to get to the spot where Jovan was. It is always, always, always the ratio that is the length of the, what do you call the side that is across the triangle? Pardon me? The hypotenuse? Opposite. Opposite means across, right? It is always the length of the opposite side divided by the length of what? Did we divide by the hypotenuse? Did we? We divided by this flat one, right? It needs a name, doesn't it? If you go across the triangle, it's opposite. The side opposite from the right angle is the hypotenuse. So this guy needs a name. It is adjacent. Opposite and adjacent are always legs. They are never the hypotenuse. Is everybody cool? All right. Now you get to put down your pencil for a second because we are going to do some calculator work now, and it's a giant pain in my butt. So please pay attention. Don't be tools. Just answer the questions I'm going to ask. Everybody have a calculator in front of them. Push clear. Your calculator should now look like this. Yes? Everybody is looking at a blank calculator with a 0 on it, right? If you're not using your phone, which you shouldn't be by now, it's a gray screen with a 0 on it, correct? Now, everybody look somewhere else on the screen. There might be some other crap on there. The only thing that matters is this. Do you see a letter D or do you see D-E-G? Some of you may see R or rad or G or grad. Is there anybody in the room that sees one of them on the screen? This is what I want. I want D or deg and that. Okay? If you see R or G, put your hand up. So anybody that does not see D or deg, put your hand up. If you do not see it. Okay, now, if you're using your phone, then I cannot help you because it's a pain in the ass and I told you to stop using your phone weeks ago. If you are using a calculator, look for a button that says DRG and it might have an arrow with it. Push that button until it says D or deg. Is everybody able to do that? And I'm sorry for all of you that have your calculator already working. This just needs to be done once. Is everybody cool? Now, if you are still using your phone, the next thing we do will allow me to know if you're in the right mode, and then I can help you out. But of course, you're going to go get a calculator, aren't you? Right. Is everybody now looking at D or deg? Every single person? You must stop me now if you are not seeing D or deg, or I don't know what I will do. I cannot guarantee my reaction. All right. Now, the next thing you need to do, every single one of you, looking on your gray screen, push clear. Your screen is now gray. There's a 0 on it. It looks like this. Push the button that says tan. If your calculator writes tan on it, put your hand up. All right. you have what I call a forward calculator. There's a fancy name for it, but it's not important. That means you do trig the way it's written. So everybody whose calculator actually shows the word tan, down here, you are going to push tan, the tan button. There's no bracket on it. Then you are going to push 3. Then you are going to push 5. Then you are going to push equals. And your calculator will show you 0.700 and a bunch more decimals. I don't care what they are. Is everybody who had their hand up for a forward calculator able to do that? Excellent. Now, if your hand was not up, you have what I like to call, obviously, a backward calculator. And being the smart people that you are, you understand that backwards is the reverse of forwards. So you must do your trig backwards from the way it is written. But there's a problem with that. Written. So you all, with a backwards calculator, are going to go, you're going to reverse this order. You're going to go 30, 3, 5, tan, and you are not going to push equals. And your calculator will show you 0.700. Is everybody good? All right. Now, Maddie, does your phone show you 0.700 with one of those two methods? Well, you should, because you're stuck with it today. So use it. Then I will be able to tell you if you're in the right mode or not. If it's a phone calculator, you're most likely are needing to follow the blue. 3, 5, tan. It's 3 buttons.
Okay, yes.
Okay. Okay. Now, all of you, using your machine, tell me these 2 decimals. Only to 3 spaces. I know your whole screen is full, but I only want 3 spaces, and I want it rounded correctly. So what is the decimal here? 0.26. Is it 7 or 8? It's 7 on the screen. What's the next decimal place? 0.2679. So that means we want 268. Don't make me do a lesson on rounding with grade 10s. Are we all good? Okay. What is 45? 1. Now we're going to talk about this for a moment. 268 as a decimal is the same thing as 268 over 1,000, correct? Everyone agree? And we know that this is this fraction. Agreed? So if I were to draw a triangle, where would the 268 go? On the right. And what would be down here? 1,000. Which means this is the angle that we were caring about. Does everyone understand Gagan? I'm sorry, what? Because the way I drew the triangle, this is the angle I care about. That is the opposite side. Just like what we were doing before. Now you have asked the question that leads me to the very next question. What if I turn this triangle over and I'm still caring about that angle right there? What's opposite to it? Over there, so that is still the 268, which makes that still the 1,000. What if I turned it this way? That's the angle I care about. Opposite, 268. Adjacent, 1,000. Is everybody cool? Now, what numbers could go there? Any two numbers that when you divide them, you got 268. And that triangle is a triangle that could exist in the real world. Is everybody with me? All right. 45 is a special one. I'll show you. If this is 45 and opposite and here, if it's 1, they're both 1, correct? Everyone agree? Because 1 divided by 1 is 1. If these two sides of a triangle are the same, and I know that this is a 90 degree, because it always has to be 90 to do trig, if that's 1 and 1, and that's 90, then what does this have to be? 45. Because 45 plus 45 is 90. 90 plus 90 is the 180 in a whole triangle. All right? So what if I told you this was 45 and I told you this was 73? How long would this be? 73. What if I told you this was pi? What would this be? Pi. What if I told you this was alligator? Then what would this be? Alligator, because alligator divided by alligator is 1. Does everybody understand? Okay. What if I told you this was 134? 500. Why? Because I halved the 268. What if I told you this was 67? What would it be? 250. Everybody with me? Because length of side doesn't matter. Everybody good? What matters is the value of the ratio. Is everybody good? All right. Class is over when? In 7 minutes? No, this is second unit. So,
I like this unit a lot.
Yeah, it's a way better unit.
okay. Whatever you guys say.
That other,
If I had started with this, you would all be crying like babies. The reason you're okay with this is because you've done a crap ton of calculations. If I had done this with you on the first day when we started with measure your locker, you would have been like,
I don't know if I would make that exact.
yeah, you would. All right. Is everyone cool?
Yeah.
Now listen. You have a test tomorrow. I don't want to go too crazy. This is where I want to stop because I need you. Remember how at the beginning of the class I asked if everyone was cool with how to name the sides, then nobody could measure them right?
Yep.
So you were lying to me when you said you were cool?
Yep.
You can't be lying to me this time.
Yep.
By Wednesday, you have to understand this part. You have to understand that we are comparing the legs of a triangle, no matter where they are turned. And you have to understand that we are comparing the opposite side to the adjacent side, and we are not talking about which side. Which is the side that we haven't even talked about this lesson? The hypotenuse. Tan is for legs only. And you need to understand that the decimal is not a measurement. It is simply the result of dividing the opposite by the adjacent. It is not a measurement. You would never say 0.268 tan equals 0.268 centimeters. You would never say tan equals 0.268 degrees. Tan is just this value. Whatever you add there, divided by whatever you had there. Does everyone understand? Is everyone really cool? Okay. Good. Your test tomorrow will not take the whole block, but you will be given the whole block. Now listen to me, because